Now let's talk about the third part of this video, the mole concept involving concentration and volume. Concentration is the amount of solute per unit volume of a solution. But sometimes many solutes can be dissolved in one particular solution, creating something that's very complicated. So sometimes it's the amount of solutes per unit volume of a solution, but most books will define it as the amount of solute per unit volume of a solution. Now, one thing that you should understand is this word solution. It looks like a very simple thing, but we can divide it into two parts. A solution is made up of solutes that are dissolved in a solvent, meaning for you to have a solution, you need to have solutes which are going to dissolve in a solvent. This word solvent might confuse you, but a solvent is just the liquid part of a solution. So if we think of the simplest solution, a sugar solution, you can make it right now. Pause the video, go and get some sugar, get some water. Get your sugar, put it in water. You'll see that the sugar, after you stir, starts to dissolve. What you make there is a sugar solution. Now, when we talk about concentration, it's the amount of sugar that has dissolved into that water. If you get a lot of sugar and then stir in that water, you realize that you have a concentrated sugar solution, or simply a very sweet sugar solution. If you put just a little amount of sugar, which are your solutes, into the solvent, which is water, you have a less concentrated sugar solution. And so under concentration, that's what basically we are talking about, the amount of solute per unit volume of a solution. And because this is chemistry, we're going to be writing this in a particular unit. And so we should know the types of concentration that might be talked about in chemistry. There are basically two types that you need to know for your secondary school. We have molar concentration and mass concentration. These two differ just as the names suggest. One is a concentration of moles, one is a concentration of mass. Now, you see this when I talk about the formulas. Molar concentration is written like this: C is equal to the moles of a substance divided by the volume of a substance in liters. And that liters is just basically cubic decimeters. And so when you're finding molar concentration, you should make sure your volume is in cubic decimeters. Meaning molar concentration can be abbreviated as C is equal to N over V. Most questions will be talking about molar concentration. However, some might involve mass concentration, so you should be able to work with both these concentrations. The SI unit for molar concentration is mole per cubic decimeters. It's very easy. And now let's talk about mass concentration. Mass concentration is just the same as molar concentration. The only difference is what's on top. You can see mole and mole. So here we'll have mass over volume of a substance. In the formula, we'll have M instead of N, and that's it. SI units will also differ. As you can see, we had mole here, which represented that we had mole on top. Now, since we have mass, and remember mass is in grams, so the SI units will be grams per cubic decimeter. This is what you need to know about basically concentration, the types and the definition. Now let's talk about examples involving these two concentrations. We're going to talk about the first example, which is not so difficult. You can handle this if you've understood the formula and you know how we've been doing everything in this series about the mole concept. Just remember to use those 4 steps I outlined so that you don't make any mistakes. Okay, let's start. A solution of hydrochloric acid of volume 200 cubic centimeters contains 0.1 moles of hydrogen chloride, and now we've been asked to find the molar concentration of this solution. It's important to understand that hydrogen chloride is a gas that when dissolved in water will form this acid. Under the topic of acids, bases and salts, we'll talk about much more of acids. Now, remember that our first step is identifying the formula to use, right? That's what we're going to do here. We have the volume and the number of moles. So we know we can use the concentration formula. C is equal to N over V. Now, next is us looking for the needed data. We need the number of moles, we need the volume. Remember, volume in the mole concept will be cubic decimeters, and so we check, is that cubic decimeters? Okay, it looks like we need to do some conversions. So step 3 we've checked, and now we need to convert this volume into cubic decimeters. What you just need to know is the proportion between cubic decimeters and cubic centimeters. The proportion is such that 1000 cubic centimeters gives us 1 cubic decimeter. Later in one of the videos in mathematics, we'll look at how these units and these proportions can be formed. Okay, since we have this, we need to put this 200 on this side and an x this side so that we can have our cubic decimeters. If we do this, then we cross multiply. You can see the 1000 multiplies with that x, so we have 1000 x cubic centimeters, and then this is equal to 200 cubic centimeters cubic decimeters. Don't worry about the units, some of them will cancel out as we continue solving. So we're going to divide both sides by this 1000 cubic centimeter that we don't need with the x. Now, the first thing we do is cancel our units just to see if everything is going the right direction. Okay, so our units are cancelled. We can see that on this side we're left with cubic decimeters, and on this side we're only left with x, which we want to find. The 1000 there cancels out, and yeah, so x is equal to 200 over 1000 times that cubic decimeters. Now, this can be simplified without a calculator. We can cancel the 2 zeros there and cancel the 2 zeros in the denominator. What this means is just that we're dividing this 200 by 100, which gives us 2, this 1000 by 100, which gives us a 10. That's what that cancelling means. But yeah, people just remember it as cancel the zeros that are common there, and yeah, you get to the answer. You can see we have 2 over 10 after we cancel the zeros. So 2 over 10 is just the same as 2 tenths, and if you know how to work with decimals, that is just 0.2. That is the volume of this solution. So next, we just need to solve this question with the data that we've collected now and get the concentration. So C is equal to N 0.1 divided by this 0.2, meaning the concentration is equal to 0.5 mole per cubic decimeter. Now let's look at example 2. In example 2, we've been asked to calculate the mass concentration of sodium hydroxide in 2 cubic decimeters of a 0.5 mole per cubic decimeter solution. The first thing is understanding which formula we're going to be using. So we check our data in this question. You can see that we have the volume and the moles, but we've been asked to find the mass concentration. So right now you must be thinking of how we can get mass and then use the formula for mass concentration to get the mass concentration. We know that if we use this volume and the concentration, we can get the number of moles. That is just simply making n the subject of the formula. Then this part, we convert it into a fraction by dividing by 1, then cross multiply. Then n is equal to CV. So this formula here can give us the number of moles when we have concentration and volume. So the concentration is 0.5. The volume of this solution is 2 cubic decimeters. So n is equal to 2 times 0.5. 0.5 is the same as half. So if we get 2 of 0.5s, we are going to have a 1. No need of a calculator. N is 1 mole. As you can see, I've not included the S. This is only present if we have 1. It's very funny, when we have 0.1, we say we have 0.1 moles. Now, we have the number of moles, so we can use this number of moles in this formula. Remember, this formula is coming from the first formula we looked at in this video. N is equal to mass over molar mass. Then we just make M the subject of the formula. You should be able to change these subjects fast, because I think in chemistry you won't be given any marks for that. M is equal to N, which we are just from finding 1. Then it's time we get the molar mass of sodium hydroxide. If you check the periodic table, sodium is 23, oxygen is 16, hydrogen is 1. If we add those, we have 40. So 1 times 40 is going to give us the mass of sodium hydroxide that was used to make this 0.5 mole per cubic decimeter solution. So mass is 40 grams, as you can see. Now we can use the formula for mass concentration, which is C is equal to M over V, to find the mass concentration. Sometimes this whole procedure might be just thought of as converting from molar concentration into mass concentration, but actually we're just finding the mass concentration using the information here, and in the process we're using the molar concentration. That's our mass concentration of sodium hydroxide in this solution. It should be noted as we are talking about concentration that all these volumes we're talking about are not volumes of the solute, they are volumes of the solution. You've finally reached the bonus tip section. In this video we've got 3 tips for you. The first, which is some common unit conversions that you need to know. We're going to start with mass. Mass can be given as tons, kilograms, or grams. So you should be able to convert from tons into grams. How do you do that? You need to know the proportions between tons and kilograms and the proportion between grams and kilograms. You should always remember that 1000 kg gives us 1 ton and 1000 grams gives us 1 kg. With these proportions, I'm sure you can handle any conversions. What you do is you convert from tons, you take into the kgs, then after you get the kgs, then you convert the kgs into grams. Now, to do that quickly, what you realize is that 1 ton will be equal to 1 million grams, because we'll be multiplying by 1000 twice. When converting from tons into kg, we multiply by 1000, again from kg into grams we multiply by 1000. So why not we just multiply the thousands in advance, we get that 1 million, and then we convert directly from tons into grams. The next is volume. Volume can be given in liters, cubic decimeters, cubic centimeters, and milliliters, or simply mils. One thing you should note is that liters and cubic decimeters are not different. Centimeters and milliliters or mils are not different also. Then you need to know the proportion between the liters and the milliliters, the cubic decimeters and the cubic centimeters. The ratios are as follows. 1 liter is equal to 1 cubic decimeter, because we know that liters are the same here, and 1 mil is the same as 1 cubic centimeter. 1000 mils will be equal to 1 liter, and 1000 cubic centimeters will be equal to 1 cubic decimeter. So if in a question you've been given the number of mils, let's say 1000 mils, you don't need to stress about it. Just remember that mils or milliliters are the same as cubic centimeters. So that 1000 milliliters will be the same as 1000 cubic centimeters. And therefore, you just equate it to the 1 cubic decimeter. You need to know how to work with these conversions. Well, sometimes when you're given units that are different, you might become stranded. Now, one thing I notice when you're converting all over in these conversions, we multiply to convert to the smaller unit and we divide to convert to the bigger unit. Furthermore, it's very funny. In chemistry, most of the units that will be used will have 1000. So if I'm converting from tons to kgs, I just need to multiply by 1000. And then if I'm converting from grams to kgs or from kgs to tons, meaning to a bigger unit, I divide by 1000. You can see that also applies here. But I don't like encouraging people to think like that. You should just multiply by the amount of the smaller unit that is equal to the bigger unit, and you'll be safe. The second tip is about subjects of the formula. You should know how to change subjects from mathematics. So in chemistry, it's just you applying that information to help you solve faster. Now, how do you change subjects of the formula very quickly? Well, there's this triangle that's commonly used by people. It has division like that and multiplication like that. Meaning, if we've got a quantity here and the quantity here. These two quantities, when divided like that, are equal to the quantity here. Let me put in some letters. Let's say we have the formula for concentration, which is Cn over V, right? It means if we cover concentration, C will be equal to N divided by V, just like you saw. And now if you want to make N the subject of the formula, we're just going to cover N and cover the division, obviously, meaning N will be equal to C times V. If we've been asked to make V the subject of the formula, or we want to use the volume in some working, then we cover the V and then we're left with N divided by C. This is one of the fastest methods in which you can change subjects of the formula just in your head. After changing a lot of subjects of the formulas using this method, you find that you can even change them mentally. You just have to imagine the triangle, cover the right unit, and then just see how everything is arranged, and you're home and dry. This brings us to tip 3, which is about molar concentration. Molar concentration is also known to be the amount of moles, or the number of moles of a substance divided by the liters of solution. This is what is termed as molarity. And to symbolize molarity, you find a capital letter M. So if in a question you find that concentration is not given as mole per cubic decimeter, you just see this big M, just remember that's representing molarity, which is just the same as molar concentration. Thanks for watching this video till the end. Now it's your job to try to answer some questions and look out for other video about the more concept. We'll be looking at how we can apply these formulas in a question paper where we've been given a chemical equation.